The next part talks about feature generation from relational databases. Here's an example of what we're going to see. So we have a relational database, and one of these tables, the students table, is the one where we're going to apply prediction over. Okay, so here we wish to predict or guess, for example, the year of a student. Okay, for a student Anna 1889, we guess that it is 4 and so on. Okay, so we have a target table, we have a label of each row, and we have other tables as well, and they are connected by foreign keys. And we might want to make this prediction by extracting features that will help us make this decision. Okay, I remind you of the setup. So the relational setup, we have a relational schema, S, consists of a set of relation names, R, the signature of every relation name, the key associated to every relation name, and foreign keys. A database maps every relation name, R, to a table, dr, okay, with the corresponding signature, so that keys are respected, no distinct tuples have the same key, and foreign keys are respected. Every tuple with a foreign key actually references an existing tuple from the table to which the foreign key references. Okay, now we have a schema S, and we focus on a column prediction task, which means that we're looking for a function P that takes as input a database, okay? And a tuple in the database. So a database D and a tuple T in DT in our notation, and outputs a number, P, D, comma, T, okay? Now, we will assume that the key of the target relation consists of a single attribute, and it is ID. It will just make our life easier, simpler. It doesn't really lose any generality, okay? Now, by feature extraction, we really mean that we build a new table, F. So it has the signature A, comma, DOM, and A includes the ID attribute, okay? And in fact, the table F will have the same keys as the target table T, and and in that sense, we are essentially associating features with every target row. Okay, so F is called a feature table, and with F defined, we can learn a module over tabular data. Okay, like XGBoost. So we can really use what we saw in the previous part. Now we're going to focus on what goes into F. And basically we're going to build one feature at a time. Call it not F, but Fi. So we're going to have F1, F2, F3, and so on. And then we'll join all of these small single feature tables into one big F, okay? We'll do it by applying a left outer join. And I'll explain what it means, but in SQL, for those who know SQL, it looks like select T and the attributes A1 to AN from T left outer join with F1 based on the equality T.id equals F1.id, and the same for F2, Fn, and so on. Why left outer join? So this is because we may not have all of the information for every tuple T, okay, in our target table, but we still want to keep whatever features we extracted for T. So for those who took the database course, remember that the outer join of two relations T and S consists of all of the tuples TS such that T belongs to T, S belongs to S, and they satisfy the join condition. But if you have a tuple T that joins with none of the tuples of S, then you add it there and pad it with nulls. Okay, so that's why we have this notation here, which is not symmetric. because it doesn't treat T and S in the same way. You preserve all of the information in T, but not necessarily all of that of S. Okay. But then you're saying we get a table with null. What do we do with it in machine learning? It's not something that we learn how to do. And you usually impute missing values. You're not adjusting the algorithm or the learning algorithm to do something with nulls, but rather replace the nulls with some values. And this can be a default value like the average or something like that, some fake value. But we do not cover it here. Okay, so now let's talk about these features that we are creating, and we look at two types: immediate features and the joins and aggregate features. Okay, let's look at the immediate features. So the first type of immediate features are, what would you use? The values that reside aside to the side of the, well, basically the features of the row, okay? The values that reside aside to the key of the row. How does it look like in SQL? Very simple. We select t.id, comma, t.some attribute A, call it AI, from T. Okay, that's very simple. But now we can say, okay, some of the information doesn't live immediately in the table, but rather it references another table as a foreign key. As so we have information about Haifa, and Haifa is mentioned in the student table. So that information about Haifa we can include in our table. Okay, so formally, suppose that we have this foreign key TB consists of contained in the key of S. Okay, T is our target table. Okay, and we denote the key by K. So we find the tuples S that are essentially referenced by this tuple T, basically S such that SK is equal to TB. Okay, and so it will look in SQL like t.id, select t.id, and then s.a. From t join s, join on what? On t.b equals s.k. Okay, now we can further chase additional references. Okay, because there are also the attributes that the referenced tuple references to. Okay, so basically, if you have a situation like T references S1 and S1 references S2, and so on and so forth, we can use all of the attributes that we see along this chain of references. Okay, for example, in the case of two tables, can be T join S1 based on TB equals S1.K1, then S2 join with S1 based on K2 or B1 equals K2. And then from S2, we use the attribute A. Okay, so that's how we bring in the features in the tuple, or the fact that is referenced by the tuple that T references to. Okay, so that's a two-step feature. Okay, so these were the immediate features. Next, we're going to look at aggregate features.